Hi everyone, in today's video we'll be learning on how to graph the inverse of a sine function. So let's get right into it. Now then, you'll see I've already graphed y equals sine of x. But what we want to find is the inverse. So we want to find y equals sine inverse of x. One thing that will help us in doing so is restricting the domain. So what you'll find is that this graph here passes the vertical line test. If I were to put vertical lines through this graph, then there'd be no repeating occurrences where the graph is touching the line twice. But on the other hand, if I were to put a vertical line through, you'd find that there are multiple occurrences where the line is touching the graph. And we do not want that because that means that the inverse of this graph will not be a function. And that's what we'll do is something called restricting the domain, where basically we're going to look at a certain piece of this graph, and that piece is going to be from negative pi over 2 to pi over 2. Now see that on the unit circle, I shaded negative pi over 2 all the way to pi over 2. And this is because all the y values in this shaded region are all unique, meaning that in this domain of the graph, there are no repeating y values, which means that when we go to graph the inverse of sine, it will be a function. Now I keep saying inverse, but what does inverse really mean? Well, inverse basically means that whatever points there are on our restricted domain, we're just going to switch the x and y values of them. And with that, you'll see that on the upper left part of the screen that I've written down the coordinates of these three values right here, and I flipped their x and y values to show the inverses. And I wrote down 1.57 because it's easier to graph it that way than just trying to figure out where negative pi over 2 is going to be on this y-axis because it's not really configured that way. And just to prove it, right, pi divided by 2 is 1.57. And with those, we can now go ahead and graph. So let's start off with the easiest one, which is 0, 0, because the inverse is literally the same. So we can go ahead and plot a point right there. Let's do the top one. So negative 1, negative 1.57. So negative 1 is going to be like a third of the way here, so we're going to go that much. And then negative 1.57, we're going to go down maybe around there. So let's draw a point right there. And 1, 1.57, so again, maybe a third of the way right there. And then up by around that much, I'd say. Again, this is all very estimating. And finally, we can go ahead and connect the dots. So we're going to come around like right there, curving in, and then we're going to curve out. And then we're just going to continue on that way, similar to how the sine graph is. You'll find that I actually cleaned up the graph a bit because it was quite messy. But this is basically the inverse of sine graphed with the restricted domain. And what you'll find to make sure it's correct is if we were to draw y equals x, so I'll do this in black. And just for like, just to be neat, I guess, I'll do a 45-degree angle. But if I were to put it right at the center here, and then draw y equals x, then you'll find that it's quite, well, I'm not a perfect artist, I'd say, but it's quite symmetrical about it. And if it's symmetrical, then that's the inverse. And before I finish things off, I just want to note that the domain and range of y equals sine of x have become the range and domain of the inverse. So if the domain of y equals sine of x was negative pi over 2 to pi over 2, that is now the range of this function. And if the range of y equals sine of x was negative 1 to positive 1, well, that's what the domain is now. So there's another concept of that inverse shown in this graph. Alright guys, if you guys found this helpful, go ahead and like the video, subscribe to the channel for more content, and comment down below if there's anything else you'd want help with. Well, that's it from me. See you later, folks.